Well, happy Tuesday, ladies and gentlemen. This is going to be a very quick review on scientific notation. You remember our old Sci Not activities? You're going to do a little bit of review with me today. There's going to be an Elastic review activity. Remember that you can always go back to your notes and use those as well, or look on Khan Academy or under the textbook as well for those tutorials if there's something that I'm not clarifying for you, because this is going to be pretty quick. I just want to go over this very, very quick. So you can wrap up the Elastic review on exponents this week with a little bit of linear review coming your way on Wednesday and Thursday. So here we go. First things first, just a reminder. Remember that scientific notation comes in the format of the first number is between 1 and 10 with a decimal point between the first two digits, and then times a power of 10, either raised to a positive exponent or a negative exponent. Remember that the negative exponent means that that number is less than 1, not a negative number. So that -3 means I would move that over 3 places to the left and make that a very tiny decimal. Okay? So scientific notation means it has to look like that. First number between 1 and 10 rather, and the second number a power of 10. First thing we're going to look at is multiplying in scientific notation form, and here we go. Let's start with this. Please do this with me. If we put down 7 times 10 to the second, and that quantity multiplied by 4 times 10 to the fifth. Reminder, again, if you need to pause at any point in this, you're more than welcome to do so, to write down and to think for a minute. But you can rearrange those numbers because of commutative property and put your 7 and your 4 together and your powers of 10 together. When you put those powers of 10 together, remember what we can do with like bases? What do we do with those exponents? We add those exponents. So we have 28 on the left and 10 to the 7th on the right. We want this to be in scientific notation form. 28 is not in scientific notation form, so that 28 needs to become a 2.8. That gets smaller. Do you remember what happens? If that number gets smaller, that number gets bigger. So we're going to end our solution in scientific notation form by just making sure we have it back in the right format. That's multiplying. Let's talk about dividing. I'm hoping this is kind of coming back to you. It's not hard stuff. We just haven't done it in a while, but I think it will kind of come back to you because we did quite a bit of this last fall and even a little bit this spring. Remember that when you divide in scientific notation, the bigger number does need to be on top. So it's either the less negative power of 10 or the bigger power of 10 on top. So let's start with 2 times 10 to the third over 8 times 10 to the 8th. Okay. Oh, I'm sorry, and I just said bigger number on top in a word problem. Excuse me. In a word problem, always put the bigger number on top, okay? This one is not the bigger number on top. My apologies. Okay, let's go ahead and walk this through because we can make it, obviously, it doesn't have to be a big number. It can be a small number, but in a word problem, the bigger number will always be on top. Our 2 over 8 becomes 1 over 4. Our 10 to the third over 10 to the 8th becomes 1 over 10 to the 5th. Because we're going to subtract those exponents, or recognize that I have 3 10s on top, 8 10s on the bottom. If I cross those out, I got 5 10s, and they're left on the bottom. I take that 10 to the 5th on the bottom, and it becomes 10 to the -5. And I just converted my 1/4 into 0.25. Am I done? Not quite. 0.25, this number is going to have to get bigger, so this number is going to have to get smaller. You got it. You got it. And 10 to the -5 to get smaller needs to be 10 to the -6. So dividing, again, the bigger number I should put in a word problem. Okay. That's only in a word problem. Okay. All right. So that's multiplying and dividing. Let's move on down. Let's take a quick look at add, subtract. Reminder, when we add and subtract in scientific notation, that's where we pull out that common power of 10. Flashback to last November, and we started talking about distributive property, and we factored out that common power of 10. That's how we started with distributive, with scientific notation. That was kind of a tough lesson. Here we go. So let's start with this. 5.43 times 10 to the third. I'm going to add to that. Notice what's between here now is a plus sign. Could be a minus sign. Doesn't matter. Same process. 3.12 times 10 to the fourth. Well, my powers of 10 are not the same, so this either has to get bigger or this gets smaller, one way or the other. And if I want this to get smaller by 1, then my decimal point has to be moved over by 1. If this gets smaller by 1, this gets bigger by 1. So my 3.12 became 31.2. It doesn't matter which one I switched. You could switch this one if you wanted to. It doesn't make any difference. If you did switch this one, this would get smaller and that would get bigger. Okay? So you could switch either one. Once I do that, I'm going to combine my two numbers and pull out my common factor of 10. Add those two things together, and I get 36.65 times 10 to the third. Can't leave it like that. Reminder, we have to go ahead and make this number between 1 and 10. 36 becomes 3.665. This got smaller. This gets bigger. Okay? I'm hoping that's enough of a review for you. I'll put a couple of links on as well for Khan Academy for videos if you want to double check some other things on Khan Academy. But that at least gets you started and helps you through the little bit of a review we have for scientific notation. Okay? Have a wonderful day.